Good afternoon, everyone, and welcome to my presentation. Let me introduce myself. My name is Vitalii Slobodzian. I am a PhD student of computer science at Khmelnytskyi National University, Ukraine. The subject of my presentation today is text data vectorization model of Ukrainian language internet communication content. Nowadays, internet technology have a really important place in non-verbal communication. It has more than 4 billion users, and due to a lot of reasons, social media audiences are significantly increasing. Availability of technology, even in poorly developed regions, general digitalization of society, and of course forced self-isolation measures because of COVID-19 pandemic is just a small list of reasons increasing social media audience. However, the internet content is not only means of communication, but it's also a critical factor of influence on people, because it can cause various collective reaction, create fear, panic, especially in content of social emergency as pandemic, war, or politically or social important circumstances. The proposed model could be used for solving following problems: determine the emotionally negative text, warn user about potentially harmful content, prevent suicidal tendencies, detect bullying on social network, and so on. There are a few issues with vectorization, especially with Ukrainian language text or internet. The biggest issue is using different languages and mixing it up. Ukraine borders 7 countries, and because of this, it's common to use borrowed words, especially in informal internet communication. One of the common issues is defected words, words that were intentionally changed to emphasize the emotional sense. For example, it sounds more offensive or funny or anything like this. Also, some approaches is important to know part of speech and any other grammatical features. And it could be a problem because of Ukrainian language. There is no innate sentence structure, and word could be in causal order. And the last issue, but not the least, it's common for all languages and all approaches. It's a grammatical mistake. Here, probably nothing to explain. It's natural that people can do mistake or even just misprints. Most of these problems are pretty hard and even impossible to avoid. But definitely text with such issues shouldn't be skipped or ignored, because such text constitute the lion's share of all everyday Ukrainian language internet content. So it was our goal to find a vectorization model that let us minimize the influence of these issues and let us catch better results. But we will talk a little bit more about this method a bit later. First, let me show our approach in more detail. On the slide, you can see the full scheme of approach for creating model. It consists of 4 steps: building of keyword vector, selection of text which can be accurately binary classified, vectorization of test text by using known keyword search method, interpret the result graphically using multidimensional scaling method. Let's look at each step in more detail. The first step is building the keyword vector. The vector will be used for following vectorization of text for classification. This step includes subtask of choosing frequency dictionaries of the Ukrainian language, combining it, limiting the number of keywords by discarding stop words and rare words. The second stage is selection of text that can be either classified when it's definitely possible to conclude that the selected text belongs to a specific category. In the third stage, each text document is vectorized by known keyword search method, TF-IDF, dispersion evaluation, text trunk, and YAC. Term frequency, inverse document frequency, is a statistical measure that evaluates how relevant a word is to a document in collection of other documents. This is done by multiplying two metrics: how many times word appears in a document and the inverse document frequency of word across the whole set of documents. Dispersion evaluation is presented as evaluation of importance of each word in the analyzed text by using a dispersion evaluation method. This method evaluates the discriminant force of word and allows getting words that are evenly disturbed from general set of commonly used words in the text. The text trunk is used for modeling text as a directed weighted graph. In this method, the keyword candidates are vertices of the graph, and relationship between two words is considered as an edge. Weights represent the frequency of occurrence in relation to age. The YAC algorithm takes into account a number of important indicators of the text, such as frequency, variety of content of word occurrence, and frequency of word occurrence in different sentences. In the first stage, the result is interpreted graphically using multidimensional scaling method. Multidimensional scaling search a low-dimensional representation of the data in which the distance respects well the distance in the original high-dimensional space. Solving the optimization problem, we find the mapping from multidimensional space to two-dimensional space, which make it possible to obtain a two-dimensional graph of the relative position of the point vector and visually accept the quality of the model for the classification task. It was proposed that visual criteria for assessing the quality of modeling, which are present on the current slide. The first criteria is high-level model of the classification. The figure A shows that the two classes are clearly separated. It indicates the correctness of the proposed model. Second criteria, an acceptable level of model for classification text. Figure B shows that two classes are tangent with each other. This result can be considered as workable, but it will require additional expert review to confirm the classification. And third criteria is unsatisfactory level of model for text classification. Figure C shows that the two classes are almost inseparable. The distance between classes is insignificant and there is an intersection in some places. This model can be considered as good and it's needed refinement. On this slide is shown the corpora that were used in this research. All of them is described in paper with all reference, so I think there is no sense to take a lot of time to describe it again. For detail, please refer the paper and let's move on. For validation of the proposed model, it was developed an experimental application. The created vector is mostly based on MovaInfo dictionary and supplemented by words from other dictionary. The resulting vector consists of 1,500 words. This length was based on research results. Also, for experimental research, were used two corpora. First is set of article about construction, karpatyboot.com.ua, and second is set of article about gardening, argomarket.net. Each of corpora contains 200 text and 500 words of each text. It's enough to use two categories to validate the proposed model and conduct experimental research because research goal is binary classification. The research was conducted for 4 methods, and the result of each of them is presented on the slide. In the first and second picture is presented the result for TF-IDF and dispersion evaluation methods. As you can see, the division of classes is not clear and there is even intersection of classes. So these methods show unsatisfactory results. In third and fourth picture is presented the result for text rank and YAC methods. Both of these methods is using more characteristics than previous one. For example, text rank method used not only the actual position of words in text, but also the relationship between words. That's why this method is show a pretty high effectivity in the division of text by category. YAC takes into account a lot of important indicators, but anyway, categories are divided not such clear. The methods show less satisfactory results. As conclusion of this study, we can identify the following results. It's established that the best ability of separation during classification text is observed at vector lengths of 1500 words. It determines the optimal dimension of the model. According to the result of text classification, it was determined that the text rank method for the keyword searching is the best method for the proposed model. It was confirmed that the multidimensional scaling method for visual analytics is an effective tool for the visual verification of the classification results. And as about further research, we are going to improve the above approaches to vectorization text. Focus research on improving general vector of words of the everyday Ukrainian language and solving problem of determining the text sentiment of message during online communication. That's all from me. Thank you for your attention.